Hello class, welcome to the last section of our studies on polynomial functions. Particularly, we are going to deal with the factors and remainder theorems of polynomial function. Under these studies, we are going to understand how division, remainders, and factors relate to polynomials. Let's look at the structure of the polynomial division. If you've previously watched the video on polynomial division, you will understand that we get to the conclusion of understanding the structure of polynomial division, where we said that the dividend is equal to the divisor times the quotient plus remainder. So under these studies, we need to understand the same concept. When dividing one polynomial by another, the division process follows the same specific structure, which is P of x, which is the dividend, is equal to divisor times the quotient plus remainder. That's for a polynomial P of x, which divides x minus a. So in this case, the x minus a is the divisor. Then our P of x will be equal to Q x plus x minus a plus r. Let's define the terms. Ideally, P of x becomes the dividend. Then the Q of x is the quotient. The x minus a is the divisor, and r is the remainder. The r here is the remainder. So if r is equal to 0, then x minus a divide P of x exactly, and then the divisor is said to be a factor. But you have to remember that the r, which is the remainder that we are talking about, can be 0 or a constant or an expression. Good. Let's walk through the remainder theorem. So we have polynomial P of x divided by x minus a. And per polynomial division, the specific structure will be of the form P of x equal to Qx plus x minus a plus r, where this particular r is the remainder. So let's find the root of the divisor. How do we find root of expression? Equating the expression to 0 and finding the value of the unknown variable that will make the whole expression goes to 0. So here the divisor will be equated to 0, which is x minus a equals to 0, which implies that x is equal to a. So by substituting the a as x as the input, then the whole expression will be P of a equal to Qa times x minus a plus r. And x minus a will be 0, 0 times the whole of this expression will be 0. So it means that when you substitute the input a, which is the root of the divisor x minus a, into the polynomial division expression in this particular form, we end up getting the output to be our remainder. So the remainder theorem states that when the polynomial P of x is divided by x minus a, it's very simple. The result is simply the value of P of a. That is the output of P of a. So how to apply this particular principle to solve problem? Number one, we have to set the divisor to 0 in order to solve for the root. Then we substitute the results of the divisor, which is 7 as the root, into the dividend, that is P of x. Then At the end, evaluate and simplify, and the result becomes what? The remainder. So let's walk through a practical example of this nature. Example 1. Find the remainder when f of x is equal to x power 3 minus 5x squared plus 4x minus 3 is divided by x minus 2. So we are looking for the remainder. So first, if we want to use the remainder theorem, then we have to let the x minus 2 to be equal to 0, which implies x is equal to 2. Then we substitute the s equal to 2 into f of x. So my f of x will be equal to x2 power 3 minus 5, 2 squared plus 4 times 2 minus 3. At the end of it all, we are going to get an expression of 8 minus 20 plus 8 minus 3. So when you add this expression, our f of 2 will be equal to minus 7. So it means that the output of the root of x minus 2 is minus 7. When we substitute the input 2 into the function f of x, we end up getting the output minus 2, and the input 2 is the root of x minus 2. So we can conclude that the remainder r equal to minus 7. So to prove that our answer is right, we can do the polynomial division of this form, where the divisor will be outside and the dividend will be inside the root. So here, x cubed divided by x will give us x squared. The x squared times the whole of this expression give us everything here. Then we subtract this one from the main dividend to get a new dividend using vertical rule of addition and subtraction of polynomial function. Then we repeat the same process where minus 3x squared, we divide x as minus 3x. Minus 3x, multiply everything here, then we get the whole expression. We subtract this expression from this dividend to get a new dividend. We continue till we realize that the degree of the remainder is less than the degree of the divisor. So at the end of the polynomial division, our remainder is minus 7, which reflects our answer as minus 7 when using the remainder theorem. Now let's work through examples 2. Find the remainder when 3x cubed plus 4x squared minus 5x minus 2 is divided by x minus 1. The same process, we let the divisor to be 0, find the root, which the root is x equal to 1. The remainder will be the output of f of 1 when the input is 1 to the function. So the f of 1 will be equal to 0. So our remainder is equal to 0. Repeat the same process here. Calculate the value m if this 2x power 3 minus 7x squared plus ms minus 26 is divided by s minus 2 gives a remainder of minus 24. So this is a very complex problem. So here let x minus 2 be 0, which means that the input is 2 and its output is minus 24, because the remainder theorem says that when we substitute the 2, it will be the same as the remainder. So r is equal to the output of f of 2. So we put f of 2 into the expression to get an expression in terms of m. So in this form, when we simplify the whole of this expression, we are going to end up with 2m minus 38. But we should note that the remainder is the same as f of 2. So 2m minus 38 is 7 as the remainder expression, which is equal to minus 24. Then we make m the subject. So making m the subject means that 2m is equal to 14 by letting the minus 3 cross the equal sign to be positive. So at the end of it, we are going to divide both sides by 2, and our m will be equal to 7. Now let's go to the factor theorem. When 10 divides 2, the result is 5 and the remainder is 0. And when 10 divides 5, the result is 2 and the remainder is 0. What does this mean? It means that 2 and 5 are factors of 10. and they divide 10 without any remainder. So it means that these 2 and 5, they are the factors of 10, and anytime 10 divide 2 and 5, the remainder is 0. That means nothing is being left behind. So therefore, the factor theorem states that if P of A equal to 0, that means if the output is 0 when you input A into the dividend or into the function, then it means that the x minus A is a factor of P of x, which means x minus A divide P of x equally without any remainder. That means nothing is left behind. Good. Now let's proceed to the important properties to note when it comes to factor theorem. If f of b over a, in this case the b over a is serving as the input, hence it is the root for the divisor ax minus b. So if b over a is being inputted into the function f of x and the result is 0, then ax minus b is a factor of f of x. Then the point 2, we have if x plus a and x plus b are both factors of a polynomial f of x, then you need to understand that their product x plus a and x plus b is also a factor of f of x. So let's walk through an example to understand all what we've said about the factor theorem. So we have to show that x minus 2 is a factor of this particular polynomial function, that is x cubed minus 4x squared plus 3x plus 2. So if x minus 2 is a factor, then first of all we should find the root of the divisor. So how do you find the root? By equating it to 0. So it means x is equal to 2. So after finding the root, let's find the remainder. How do you find the remainder? We input 2 into the dividend, which is the function, to see the feedback or the results. So after that, we are going to realize that when you input 2, your final answer will be 0. So hence the remainder is 0. Therefore, since the remainder is 0, it means x minus 2 is a factor of f of x. Why? Because it divides f of x divide x minus 2 without any remainder, because we end up getting the answer for the remainder being 0. Hence x minus 2 is a factor. So let's look at the example 2. It's a very complex problem here. We have if 2x minus 1 is a factor of the polynomial f of x equal to 2x cubed minus 5x squared minus kx plus 3. Find the value of k. So if 2x minus 1 is a factor, then for 2x minus 1 equal to 0, we have 2x equal to 1, which implies that x will be equal to 1 over 2. And the remainder will be the same as f of 1 over 2. Imagine, in this case, we are saying that 2x minus 1 is a factor, so hence the remainder is automatically equal to 0. So f of 1 over 2, 7 as the remainder, will be equated to 0. So anywhere we see x, we substitute 1 over 3, as you see here. So we have 2 into bracket 1 over 3 power 3 minus 5 into bracket 1 over 2 power 2 minus k 1 over 2 plus 3 equal to 0. Then we simplify the expression at my left side here in order to make sure we make k the subject. So when you simplify to make k the subject, we end up with minus 2k plus 8 equal to 0. Then 8 equal to 2k, so k equal to 4. It means that anytime you substitute 4 as k, then indeed 2x minus 1 will be a factor of the polynomial f of x. Good. So this is a simple try work for you. Thank you for listening to this particular channel. Don't forget to subscribe and send your answers and your feedback by pausing the video to solve this particular problem, and your results supposed to be sent through me or through my WhatsApp contact or this particular channel. Don't forget to subscribe. Thank you. God bless you. Bye.